Hi everyone. So today in this session, we are going to discuss the AIET test. Uh, Everybody knows that, and I am assuming that everyone has given the test. They have performed well, and they have analyzed the questions and the result as well. So now in this session, we will discuss most important questions of the test, which I feel like are important, and we will try to cover all the concept related to the questions. Is this thing clear? So it is not like question solving, it is the effort in which I will try to deliver the concept as well. So let's start the session without wasting any further time. So this is the first question on your screen. First question of your test. So what it says the electric field due to a uniformly charged sphere of radius r. Okay. So there is a uniformly charged sphere, like this is a uniformly charged sphere. Uniformly charged, something like that, like this. Let's suppose this charged sphere has some charge q, total charge q, and charge density as rho. Clear? So what you need to discuss, what are the options? It says the electric field versus position graph we need to discuss. So there are certain possibilities, like this is the center and it has a radius r. So if I see for any point which is inside at a distance r, so what I say, first case I will say at any point r, which distance is less than the radius. That means this is inside sphere point. And I hope while studying the applications of Gauss theorem, you have studied the derivation for that. So this field, you can write that E is equals to rho r divided by 3 epsilon naught. This is the field inside the sphere. And from this, you can conclude that field is directly proportional to the r. And this indicates that graph will be a straight line passing through the origin. So graph will be a straight line passing through the origin before the radius. So this is the case in two cases, E proportional to R here and E proportional to R here. In these two cases, this condition satisfies. Now, second case, which is outside, I say for R greater than the radius, that means any point outside the radius, that means outside the sphere, or you can say outside the sphere. How the field is calculated, everybody knows that E can be calculated by considering the sphere as a point charge. You can consider the sphere as a point charge, like here, this is the complete sphere, and you can consider it a point charge, and the charge is Q. Total charge of the sphere is Q. At a distance what? At a distance R. So it is written as Ke, which is electrostatic constant, Q by R square. So from here, you can conclude that E is reciprocal to R square. So graph of E is reciprocal to R square is mentioned. This is the graph of E reciprocal to R square. So hence option B is correct answer. Clear? I think it is quite simple question. Move further. Another question. What it says, pause the video, try to read out the question, try to understand the concept, and then listen to me again. For a cell, terminal potential difference is 2.2 volt. Now, sentence is not complete yet. When circuit is open. Now, up to this point, sentence is completing. Sentence completes up to this point. Now, when circuit is open, the potential difference is 2.2 volt. Now, listen to me here. Let's assume there is a cell which is connected to a resistor and a switch like this. This is resistor R, cell has some EMF E and has some internal resistance R. This is simple circuit. Now, as you can see, the switch is open. So this is open circuit. Now, whenever the circuit is open, try to note down my line. Whenever the circuit is open, the terminal potential is equals to the EMF of the cell. That means when circuit is open, the punchline is the terminal potential and the EMF both are same. So from this line, I can see that EMF of the cell is 2.2 volt. Is this thing clear? Because question is saying when circuit is open, the terminal potential is 2.2 volt. After reading the first line, I can say that the EMF of the cell is 2.2 volt. Now moving further. And reduces to, the line again says, and reduces to 1.8 volt when cell is connected to a resistance 5 ohm. Now this cell is connected to a 5 ohm resistor. Connection is made, switch is closed. Okay. Then determine the internal resistance of the cell. Now we have to determine the internal resistance of the cell. Now, when the circuit is closed, you can see that a current will flow like I is flowing through the circuit. Clear? Now this cell is in discharging mode. It is providing current. So in this situation, terminal potential V can be written as E minus IR. This is the standard formula. You have studied it in your classes. V equals to E minus IR, where E is the EMF, V is the terminal potential, I is the current through the circuit, and small r is the internal resistance. Now I know the values. What is I here? Current. Can you calculate the current? Yes, I can calculate the current. You can see the current here. For this circuit, if you apply Ohm's law, I is equals to EMF divided by total resistance of the circuit. Total resistance is R and this small r, both are in series. So total resistance is 5 plus R. Total resistance is 5 plus R. This is Ohm's law. So we know the value of current. Now putting the values. V is 1.8 volt is equals to EMF is 2.2 minus I is E upon 5 plus R. E is again 2.2 divided by 5 plus R into R. I have placed the values. Now we need to calculate R. You need to simply solve it. So I can say 1.8 is equals to, I can take 2.2 as common. So it will be 5 plus R minus R divided by 5 plus R. Now, this is simple calculation. What I did here, I have taken 2.2 as common. So after that, it will remain 1. This portion will remain 1. I have taken LCM and solved it. Quite simple steps. You can do it by yourself. So this R and R can be cancelled out. This decimal and decimal can be cancelled out. So it will be written as 18 by 22, clear, is equals to 5 by 5 plus R. Clear? You can again simplify it. 9 by 11. Cross multiply. 45 plus 9R is equals to 55. So you can see that 9R will be 10. So R will be 10 by 9 ohm. R will be 10 by 9 ohm, which is our correct option number. Tell me the correct option number. Yes, this is correct option number A. Is it clear? Yes, sir. It is clear. Now moving for the next question. Try to read the question, pause it. Clear? Now, what it says, there are two bar magnets. Okay, I am reading the question. Two bar magnets having same geometry. Okay, same geometry means their length and width, every mass, everything is same. With magnetic moment M and 2M. Okay, everything is clear till now. Are firstly placed in such a way that their similar poles are on the same side. Then its a time period of oscillation is T1. Now I will stop here. Now I got an idea that what question demands. They are dealing with time period of the bar magnet. So I will recall first thing after reading this statement that came to my mind. I need to recall what I need to recall. I need to recall the time period of a bar magnet. So let's suppose this is a bar magnet. This is, let's suppose, South Pole, this is North. And this bar magnet is placed in an external magnetic field, let's suppose B. This is the external magnetic field. So it's a time period. Okay, this external magnetic field will try to rotate the magnet. So it will, you know, the concept of dipole moment. It oscillates in the field, along the field, or to and fro of the field. So this magnet will start oscillating, and its time period is 2 pi root of I over mb. Don't worry, I will explain each and every term here. T is the time period. I is the moment of inertia. What is this? Moment of inertia of the bar magnet. M is the magnetic moment. B is the magnetic field. Clear? Okay. Now, first case, they are saying firstly in such a way that their similar poles are on the same side. Now, suppose these are the two bar magnets. Their similar poles are on the same side. Let's suppose south, north, south, and north. One has a magnetic moment M, another has a magnetic moment 2M. This has a magnetic moment M, this has a magnetic moment 2M. So net magnetic moment, because they are placed in the same direction, their magnetic moments are also in the same direction. The direction of magnetic moment is from south pole to north pole. Note it down. If you don't know that, you can note it down. The direction of magnetic pole is from south to, magnetic dipole moment is south to north. So total magnetic moment in first case, what I have written, M1 net in the first case is equals to 3M. Clear? Now for the second case, if I talk about, let's take another pen. Now this time, one of the magnet is reversed. Now the polarity of one of the magnet is reversed. Don't worry. We will reverse the polarity. Let's suppose this is again south, north, south, north. Now polarity is reversed. This is M in the right direction. This is 2M in the left direction. South to north, now everybody knows. So total magnetic moment of this system, you can see one is in the left, another is in the right. So they will subtract. So net magnetic moment is M. In which direction? In left direction. So direction is not required in this particular question. So I have written the magnitude M. Now time period. If you see that time period here in this relation, 2 pi is a constant. Moment of inertia is going to be a constant because they are identical or same magnets in terms of geometry. So field, they are not discussing whether field is same or not. So we are assuming field to be same. So what happens? T you can remove the constant terms. So T is reciprocal to magnetic moment square root. So you can write as T1 over T2 is equals to root of M2 over M1 net. Now place the values. T1 over T2 is equals to M2 is M, M1 is 3M. So it will be, what will be the result? T1 over T2 will be 1 by root 3. So from this conclusion, you can see that T2 is greater than T1. T2 is greater than T1, which is again option number 1. Clear everything? I think every concept is clear till now. What you can note down from this concept, you can note down this one thing. Another thing, the direction of magnetic moment you can recall, that is from south pole to north pole. And if they are in same direction, they can be added. If they are in opposite direction, they can be subtracted. Like vector addition. Clear? Another question. This is a good question. It seems to be a good question. Okay. A block of mass 10 kg is moving in x direction with a constant speed of 10 meter per second. Now, try to imagine things in your mind. Try to draw a rough picture in your mind that there is a block of 10 kg. You can forget about the masses. Just leave the mass, but there is a block which is moving in the x direction. Now, till now everything is clear with a certain velocity. Again, it is subjected to a force minus 0.1x. Now, as soon as I see this force, one or two things that should come in my mind. That one thing is that this force is variable. It depends on x. This is a variable force. First thing. Another thing, the minus sign indicates that this force is opposing my motion. Because if my motion is along positive x-axis, this force should be in negative x-axis. Because the minus sign indicates opposition. Now, from where to where? From 20 meter to 30 meter. Okay. So it's final kinetic energy they are asking. Now, first of all, I will draw the situation. This is our x-axis or this is our horizontal surface. There is a block. You can see its mass is 10 kg and it is moving with uniform velocity 10 meter per second. Clear till now? In this direction it is moving. From x equals to 20 to x equals to 30. There is a force acting on the block. And after that, they are asking the final kinetic energy. That means once it reaches x equals to 30 mark, they are asking me the final kinetic energy of the block. That means at this point, let's suppose this is point A, this is point B. At point B, they are asking me the kinetic energy. Now, what I told you, the force is applied opposite to its motion. That means, can you see that its velocity will decrease? Its velocity will decrease, so final kinetic energy will be somewhat lesser than the initial kinetic energy. Yes, sir, that is very clear. Now, again, if I say, what can you do? What can you do to get the kinetic energy? Now, recall again. This force will do some work, and everybody knows that there is a very standard theorem in the work energy chapter, work energy theorem. Work energy theorem, what it says, that total work done is equals to change in kinetic energy, K final minus K initial. This is the golden statement. Now, what you need to do, calculate the total work done. From where to where? Force is applied from 20, only in this duration, force is applied. And how much force? 0.1 x. Clear? This is the force. Now, this is a variable force, so work done will be calculated using integration. So how you will calculate the work done? Work done will be integration of force. Force is minus 0.1 x dx. This is work done. From where to where? 20 to 30 is equals to K final minus initial kinetic energy, half, mass is 10, and initial velocity is 10 square means 100. Clear? Now this is very simple integration. If you see the integration part, minus 0.1 is this one written. Integration of x will be x square by 2. Limits are from 20 to 30 is equals to k final minus. You can solve it. This is 5 times 100 into 5. This is 500. Every step is clear till now. Now you can put the limits. Minus 0.1 divided by 2. If you can see that upper limit minus lower limit, upper limit is 30. 30 square means 900. Minus 20 square means 400. 900 minus 400, that is 500. Clear? So that will be 500 is equals to k final minus 500. Now next part I will do on this side. Okay. You can simplify it. That is 250. 0.1, that means 25. Minus 25 is equals to k final. Or can I transfer this? Can I transfer this 500 to this side? Will it work? Plus 500. This minus 500 will become plus 500 is equals to k final. So k final is 475 joule, which is again option number A. Now listen to me. This is most of the time it will work that I'm going to tell you. Whenever a question is asking for the kinetic energy, try to find a way to apply work energy theorem. 99% cases question demands you to apply work energy theorem. So whenever a question is asking for, in mechanics I'm asking mostly, I am telling you, if question demands for velocity or the kinetic energy, try to find a way to apply work energy theorem. And in 99% cases, your question will be done. I think this question is clear to you. Moving further for the next question. Okay. This is again a very good question. What it says an engine pumps water through a hose pipe. Okay. Nothing special in that. Water passes through the pipe and leaves it with a velocity 2 meter per second. Okay. The mass per unit length of water is something given. What is the power of the engine? Okay. So let's draw it. What is say? Let's suppose there is a pipe. This is a pipe. From this pipe, some water is coming with certain velocity. Let's suppose v, and this velocity v is given as 2 meter per second. Clear? Now we need to find the power delivered by the engine. So we know that power delivered is F into V. Now we don't know the force. We don't know the force. We know the velocity of the water coming out. So I'm assuming few things here. Let's suppose, can you imagine that water is flowing through the pipe, something like that. Something like that. So let's suppose some cross section of the water at some time is at this position. Now in a very small time dt, this portion of water will be here. And in this duration, the water moved through this cross section. Let's suppose its mass is dm and the distance traveled is dx. Are you getting my point? In dt time, the amount of water that passes through this cross section is, let's suppose mass is dm, the length it covers is dx. In what time? In dt time. Clear? So this force, this is power. Force, everybody knows that can be written as rate of change of momentum, that is dp over dt. So don't get confused by this p and p. This capital P is power, this small p is momentum into velocity. Clear till now? Now I'm moving further. P is equals to d over dt. I'm writing this velocity here, v. P can be written as mass into velocity. That, sorry, momentum can be written as mass into velocity. Now moving further. Power is written as this v is the velocity. Now you can see that velocity is constant, which is 2 meter per second. So I am taking this v constant outside. So it will become v square dm over dt. Okay. Now I am doing one trick here. I am multiplying dx and dividing by dx. By doing so, I can rearrange this equation. Can you see that power is equals to v square is already there? I am rearranging it dm over dx into dx over dt. This dx over dt is again velocity. So this power can be written as, this is again velocity, v square is already there, so it will become v cube dm over dx. Now this dm over dx, you can see that dm is the mass, dx is the length, so dm over dx is mass per unit length. And this mass per unit length is given as 100 kg per meter. This mass per unit length is given as 100 kg per meter. Now I will put the values. So after putting the values, you will get a very decent result. P is equals to, velocity is 2 cube into dm over dx is 100 kg per meter. So can you see that P will, power will become 800 watt. Power will become 800 watt, which is again option number A. What's happening here? I don't know what's happening, because most of the options till now I can see are option A, except one question. Everything is option A. I am not recommending this to anyone, like something like that. Okay, moving on to the next question. Read the question first. There is some diagram given. A particle is projected with a velocity 10 meter per second at an angle 37 degree with the horizontal. Now for this situation, there is a diagram given like this. This is the diagram given. Now it reaches to a point P in 1 second. It reaches certain point P in 1 second. No problem. Now the direction of gravity is changed by 37 degree with the vertical as shown. Okay, the direction of, this is the second situation. The new projection velocity so that the particle reaches the same point P in 1 second. Now, after reading the question, one thing is very clear in my mind, that there is a point P. The particle needs to reach this point P in both the situations. That means, first thing, the first aim of mine is to find the location of this point P. Very clear. Yeah, your aim, your small goal should be very clear. So I am drawing the diagram, rough diagram, I will say. Let's suppose this is horizontal, this is vertical, and particle is thrown something like that. It will travel like that, I am assuming, with some initial velocity. This angle is 37 degree. Clear? And after 1 second, let's suppose it reaches a point P. It reaches a point P. So till point P, it has some y coordinate like that. It has some y coordinate. It has some coordinate. Okay, sir. So we need to, first of all, we need to find this x and y. After that, we will solve for the second part, the change in the direction of gravity. Okay. For that, you must know the horizontal velocity. I think everybody knows that projectile motion is a combination of two motions, horizontal and one vertical. If you see that, its horizontal velocity, you can see that its horizontal velocity is, I can say, velocity in the x direction is 10 cos 37. Is it clear to everyone? I'm taking the component. Initial velocity in x direction 10 cos 37. If you place the values, that will be 10. Cos 37 is what? 4 by 5, 5, 2, 2, 4, 8. That is 8 meter per second. Done. Its vertical velocity will be 10 sine 37 degree. Sine 37 is 3 by 5, 5, 2, 2, 3, 5. That is 5 meter per second. Clear. Correct me if I am wrong. Okay. Yes, I am wrong. 5, 10 into 3 by 5. That is 2, 3 is 6. That is 6 meter per second. Clear. Now I know the horizontal and vertical velocities. I am applying the motion. First of all, I am applying the motion in y direction. Up to which point? Let's suppose this is our origin. I am applying the motion up to point P in y direction. So what is the equation? S equals to ut plus half at square. This is the general equation. This is general equation. If I put the values, so displacement is what? Y is equals to, initial velocity in y direction is 6, time is 1, minus half, g is 10, t square is again 1. This is second kinematic equation, nothing else. So y is equals to 6 minus 5, that is 1. So we got y coordinate. Now similarly, you can get x coordinate. Okay, we can get x coordinate as, in x direction, if I apply, the acceleration due to gravity is in the y direction. There is no horizontal acceleration. If there is no horizontal acceleration, what you can say, x is equals to, or the distance in the x direction is equals to speed into time. What is the speed? In horizontal direction, speed is 8 meter per second. 8 meter per second. Time is what? 1 second. Distance is equals to speed into time. So x coordinate is nothing but 8 meter. So we got x and y both. Now in the second situation, just now be careful. What's new in this case? If you can clearly see, if you can observe the situation, in the first case, the acceleration due to gravity is vertical. There is no horizontal component. Now the acceleration due to gravity is not vertical, it's something tilted. So what, can you see this pen? If it's not blurry, can you see this pen? Is it in focus? Yes, it's in focus on my face only. So I hope you can see that. So if this is vertical, then there will be not vertical, then there will be a vertical component, y component, and there will be a horizontal component as well. That means this time acceleration will be in both direction, x and y. Clear? Now, what will be the values of these accelerations? You can see that. Let's suppose this is our y-axis This is our x-axis. This is the acceleration, which is 10. This is g, and at what angle? It was given as 37-degree angle. Now, if you take the components, this component will be 10 sine 37. Clear? That is g sine 37. You can say g is the acceleration due to gravity. 10 sine 37 means, again, you can see that sine 37 is again 3 by 5, 5, 2, 2, 3, 6. That is 6 meter per second square. And in y direction, this component will be 10 cos 37. So that will be, again, if I say cos 37 is 4 by 5, 5, 2, 4 is 8. That is 8 meter per second square. This is the acceleration due to gravity in x and y direction. Again, the particle is projected. Let's suppose this is x, this is y. Let's suppose the particle is projected with some velocity u at an angle theta. At an angle theta. So we need to find out the velocity. Again, I am applying it in y and in x direction. In y direction, component, if I say, that will be u cos theta, I am doing it quick now. This is u sine theta. This is the component of velocity. In y direction, if I apply, what is the equation? I am writing the equation as is equals to ut plus half a t square. This is the equation, standard equation of kinematics, second equation of kinematics. Now the displacement is again must be same as the previous one, because it is going to be going to reach at the same point. So displacement is again y, and y is what? 1. Y is what? 1. So I'm writing it here. 1 is equals to, initial velocity is u sine theta. Time is again 1 second, no problem. Minus. Now half. Acceleration is what? 8 meter per second square downward into 8 and 1 square. Is this point clear? Why I am choosing minus here? Because this is downward. That's why I am writing the acceleration as minus. And how much magnitude of the acceleration due to gravity in the y direction is 8 meter per. It's not 10, it's 8, because you have taken the component here. So what you can say here, this is going to be 4. This 4 will be transferred here, 5. So u sine theta is equals to 5. Let's suppose this is equation number 1, if there is nothing formed in the term of equations. So u sine theta is equals to 5. Now, similarly, if I apply the same equation in the x direction, if I apply the same equation, I'm applying the same equation, which is s equals to ut plus half at square. This is the same equation I'm applying. Displacement is what in the x direction? Displacement in the x direction must be 8. So 8 is equals to, velocity in the x direction is u cos theta. Very good. Time is again 1 second, so I'm not mentioning here. What is the acceleration? Is 6 meter per second square. Acceleration is what? 6 meter per second square. Plus, this is in the right direction, positive direction. So that is half. A is what? 6. Time is what? 1 square. So you can clearly see that 2 3s are 6. This is 8 minus 3, that is 5. So u cos theta is equals to 5. This is equation number 2. So by looking at these two terms, 1 and by 2 equations, u sine theta and u cos theta, you can get the values of velocity u. There are various ways. One way to get the velocity u is you can square and add. I'm squaring it, square 1 plus square of 2 and then add both these two equations. So what you will get, I can write it here. If you square it, you will get u square sine square theta plus u square cos square theta is equals to 50. How 50, sir? Square 25, square 25. If you add, it will become 25 plus 25, 50. So it is u square sine square theta plus cos square theta is 1 is equals to 50. U is equals to 5 root 2 meter per second. U is equals to 5 root 2 meter per second. Which option is correct? Option C is correct. Is it clear to you? Question is not difficult, a bit lengthy because I am solving it, so it feels like a bit lengthy, but it is not. Moving further for the next question. A block of mass m is placed on a smooth wedge of inclination theta. Very good. The whole system is accelerated horizontally so that the block does not slip on the wedge. Okay, so let's draw it. First of all, I will draw. Let's suppose this is the wedge. On this wedge, there is a block of mass m, like this. There is a block of mass. Clear? Okay. It is accelerated horizontally so that the block does not slip. The force exerted by the wedge on the block. Okay. Now, first of all, I will draw a simple FVD. If you can see, first of all, there will be a weight mg, which is vertically downward. Very good. There will be a normal reaction n, and this inclination is given as theta. Now, if you can draw the components, this component will be mg cos theta. This angle is going to be theta, and this component will be mg sin theta. Now, till now, everything is clear. This is simple question. Now, something special happens. This wedge is moved horizontally. Let's suppose this is moved horizontally with some acceleration a, so that this small block is not moving on the wedge. This is the case of non-inertial frame. If you are viewing it from this frame, this is a case of non-inertial frame, and there will be a pseudo force. There will act a pseudo force, which is okay, which is opposite to the acceleration of the frame. So this pseudo force is ma. Clear? You know the concept of pseudo forces. What are the pseudo forces? When the frame is non-inertial, then there is a pseudo force acting on the body. So if you again draw the components of this ma, the components will be something. If I take another pen, the components will be, one component will be along this line, and one component will be along this line. Now, for that, you need to identify this angle. What will be this angle? Okay, this is our y, this is our x. Now, y is tilted by theta, so x will also tilt by theta. So, this is angle theta. This is ma cos theta, and this is going to be ma sin theta. Now, we have done the components. Now, you can balance the forces. What is the question? The force exerted by the wedge on the block. The force exerted by the wedge on the block is nothing but the normal reaction. We need to calculate this normal reaction. Clear? So now in y direction, if you can see, what will be the equation? N will be equals to MA sine theta plus MG cos theta. That will be MA sine theta plus MG cos theta. You can see that. MA sine theta plus MG cos. This is equation number 1. Now, in x direction, I will change the color of the pen. In x direction, you can see that MA cos theta will be equals to mg sine theta. Sir, how these forces are equal? Because the block is not moving, the block is at rest. That means the horizontal forces and the vertical forces must be in the balanced state. That means all the horizontal forces, the sum of horizontal forces must be zero. Similarly, sum of vertical forces must be zero. That's why what I'm applying here. Horizontal forces, if you can see, mg sin theta and ma cos theta both must be equal. So from here you can calculate m and m can be cancelled out. A is nothing but g sin theta over cos theta. Is it clear? Am I right? A is equals to g sin theta over cos theta. Now place this value in equation 1. I am placing this value in 1. N will be m. You can take m as common. What is the value of A? A is g sin theta over cos theta. So it will become sin square theta plus ka g cos theta. Is it clear to everyone? I have placed the value of A, nothing else. Now, if I solve it further, m is already there. What's happening? I don't know what's this. Okay, I think it is zoomed equation. Okay, how can I write? Okay. What is this? Okay, this is not the live class. You can't help me in this. What I did? What I did? Okay, it's done. Sort out. So you can take G common and I am taking LCM. So LCM will be cos theta sin square theta plus cos square theta. I know everyone knows how to take the LCM in such situation. LCM will be cos theta. Cross multiplying it, G is already common. So this numerator will become 1. So final answer N will be mg divided by cos theta. This is your final answer, which is mg divided by cos theta, which is option number C. Okay, so not all the answers are option A. This is option C. Moving further for the next question. This is a good question. An infinitely long non-conducting cylinder. Non-conducting cylinder of inner radius something 5, outer radius 7, has uniform volume charge density something this one. The magnitude of electric field at a distance 10 centimeter from axis of cylinder. Now, as soon as I read the question, what comes to my mind that there is a cylindrical body of infinite length which has some inner radius and some outer radius, and field is asked at a point 10 centimeter. As soon as I see this 10 centimeter, it comes out to my mind that this point is outside the cylindrical body because the maximum radius of the cylindrical body is 7 centimeter. So this is the case of calculating field outside the body. You can use Gauss theorem. So how this cylindrical body is looking, this is of infinite length. I can't draw this infinite length. I am drawing it something like that. Let's suppose this is the axis. This is the axis of the cylindrical body. Clear? And in this portion, there is certain charge. Clear? Positive charge. You can see that in this portion, there is positive charge. Let's suppose its density is rho. The charge density is rho. Clear? Now you have to calculate the field at a point something outside. One radius is R1 inner radius and outer radius is R2, which is 7 centimeter. So what is the condition? You need to draw a Gaussian surface. So let's suppose this is our Gaussian surface and this is the point where field is asked. And this distance I am supposing it to be R. Clear? I think till now everything is clear. Now, what is the statement of Gauss theorem? Total flux is equals to charge inside divided by epsilon naught. So what is the total flux through this cylindrical body? One portion is this cap, another is the bottom. Out of these two regions, there is no field. Field will be linked, flux will be linked only to this curved part. And the flux that is linked with this curved part will be, I am applying Gauss theorem. What it says, flux total is equals to charge inside divided by epsilon naught. This is the statement of the Gauss theorem. What is the total flux? Let's suppose field is E and let's suppose the length of this portion is L. 2 pi R L is equals to how it came. Everybody knows that. Flux is linked with this curved portion only. Area of this curved portion is 2 pi R L. 1 by epsilon naught. Now there comes the question, what is the value of charge inside? So for the calculation of charge inside, I am taking some portion of this page. Let's suppose I am taking this portion of the page for the calculation of charge inside. Okay. So charge inside will be nothing but rho into dV. This is the golden term. Now, if you can see, charge inside of what? Charge inside of the Gaussian surface. So this is our Gaussian surface, that blue colored or something sky blue colored is the Gaussian surface. And in this surface, what charge are included? Only charge in this region. In this region is included. If you can see, this is cylindrical body and charge of this portion of this length is included. So what is the volume of this portion? What is the volume of this portion? You can see here, charge inside is equals to rho is here. What is the volume? The volume of the cylindrical body is pi r square h, but the inside part is hollow. So what I am trying to do, I will calculate the volume of this outer cylinder and subtract the volume of the inner cylinder. So we will get the volume of this portion. Because the length is infinite, so what length should I consider? The length of the Gaussian surface, which is L. So this is pi R2 square L minus pi R1 square L. This is the desired volume. So you can again write it as rho pi L is common, R2 square minus R1 square. This is the charge inside. So I can close this box because this is just the calculation of charge inside. Now put the values of charge inside. Rho pi L R2 square minus R1 square, bracket closed. Now you can, it's your task to simplify actually. From these two terms, pi and pi, L and L can be cancelled. Clear? So E will be what? In the numerator part, rho R2 square minus R1 square. Very good. Divided by 2R epsilon naught. 2R epsilon naught. Now place the values. So if I place the values, it will become E equals to rho is what? 8.85 into 10 raised to the power minus 9. Okay. R2 and R1, 7 and 5. 7 is what? Centimeter. If you square it, it will become 49 into 10 raised to the power minus 4. Clear? 7 centimeter. Now, if you square it, it will become 49 into 10 to the power 1. So 49 minus 25 and 10 raised to the power minus 4 is taken common from both. Divided by 2. R is what? At what distance? 10 centimeter. 10 centimeter is what? 10 raised to the power minus 1. Epsilon naught is what? 8.85 into 10 raised to the power minus 12. Now you can cancel out the things here. This 8.85 will be cancelled. Very good. Powers 9 and 4, 13. 12 and 1, 13. So all these powers, 13 and 13 powers will be cancelled. That means there is no power left. 49 minus 25 is nothing but 24 by 2. That is 12 Newton per Coulomb. This is our answer, which is option number A. Is it clear to you? This is simple application of Gauss theorem, nothing else. Moving further for the next question. Okay, another question says, a monkey of mass 20 kg is holding a vertical rope. Okay, the rope will not break when a mass of 25 kg is suspended from it, but will break if the mass exceeds 25 kg. That means the maximum tension it can hold is 25 kg. What is the maximum acceleration? Okay, let's draw the diagram. Let's suppose this is the rope. No, this is the rope on which there is a monkey. I am trying to draw a monkey. I don't know. I am not a very good person. Okay, this is a monkey. Very good monkey. These are the eyes of the monkey. Okay. So this monkey is climbing upward. Its weight is something given as 20 kg. So the weight is given as 20 kg. That means downward force is 200 mg. Everybody knows that mg. Let's suppose tension in the string is T. And again, let's suppose the monkey is moving with some acceleration A. Okay. So if you can write the equation T minus 200 is equals to 20A. Someone may ask, sir, what's happening here? Net force is equals to mass into acceleration. Net force is what? T is upward, 200 is downward, mass is 20, acceleration is A. Now this T is what? Maximum tension, because we need to calculate the maximum acceleration. So for maximum acceleration, I can say tension should be maximum, because after this acceleration, the rope will break. So maximum tension in the string is, everybody will say that it is given as 25 kg. 25 kg means 250 Newton. That is 250 minus 200 is equals to 20A. Okay, so 50 is equals to 20A. So A is equals to 2.5. meter per second square. Basically, this is very simple but widely asked question in the mains exam. So be familiar with these type of questions. I think everything is clear till now. Okay. So which is option number D? Moving further. Okay, this is again a very good question. Most of the students get wrong answer of this particular question. They don't know the concept exactly. Can I drink some water? Okay. So there is a ball. You can read the question, you can pause the question. I am dealing with the diagram straight away. What it says, okay, I can draw these axes. Like suppose this is y axis, sorry, this is x axis and this is y axis. Clear? Now the ball is coming. Let's suppose ball has some momentum p while coming. And they say it is reflected with the same speed at the same angle. With the same speed, mass will also remain same of the ball. So the momentum of the ball going away is also p. Is it clear? Okay. Now can you see that we need to calculate the force acting on the ball? Like this ball is striking here, it will strike somewhere here and it will reflect back. So how much force it has applied? So this is a case of impulse, nothing else. This is the case of impulse. So what is impulse? They are asking the average forces. J is equals to F into delta T. So they are asking the force. They are asking the force. So first of all, we need to calculate the impulse and time duration they have given. This delta T is given. This is being asked. So for that, we need to calculate this J. Clear? From impulse momentum theorem, everybody knows that, everybody should say that delta P by delta T is equals to F. Delta P by delta T is equals to F. So can you calculate directly F from this equation? F is equals to delta P by delta T. Delta P is what? Change in momentum. Delta T is the time duration. So you can directly calculate force, average force using this equation. So we need to calculate the change in momentum in this particular question. So change in momentum we need to calculate. Okay. Coming to back to the question. Let's suppose this is initial momentum. If you can draw the components, this component will be P cos 30 and this component will be, I'm writing it here, P sin 30. This is the initial momentum. These are the initial momentum with the red color. Now I will change the color of the pen. Let's suppose this is the color. Now outgoing momentum is this one, P. What are the components of this? This one is P cos 30. I am assuming that everybody know how to take the components. And this one is P sin 30. Is it clear to everyone? Now you can see that red color is the initial momentum in x and y direction and the blue color of whatever the color you can say is the momentum in the y direction. Now clearly you can see that initial and final momentum in y direction is the same. I am not talking about the magnitude. I am also talking about the direction. The direction in the y direction of the momentum is in initial and final situation is same. That means there is no change in momentum in the y direction. But if you see in the horizontal direction, magnitude is same. That's clear. But initial momentum is in the positive direction, but final momentum is in the negative x direction. That means momentum has changed its direction. So what is the change in momentum? What is the change in momentum? I can say here delta P is equals to P final minus P initial, and I am writing in x direction only. So final momentum is of blue color, that is minus P sine 30. Minus sign is here, minus P initial is P sine 30, that is minus 2P sine 30. This is the change in momentum in the x direction. Can you see that sine 30 has a value 1 by 2 and this 2 can be cancelled? Clear? So what is the change in momentum is P. This negative sign is just indicating the direction. Now you can place the values. F is what? Delta P by delta T, that means P over delta T. P is what? Momentum, mass into velocity. Mass is what? 0.5. Velocity is what? 12. Divided by time period is what? 0.25. Can you see that this is going to be 2? So force is equals to 24 Newton. This is our answer, 24 Newton. 24 Newton is option number B. Is the statement clear? Or from here, you can also see that this J can be written as delta P. Impulse momentum theorem is equals to F delta T. So whatever the case you apply, I have directly written this one, or you can go this way as well. Nothing is to worry about that. But the concept is that you need to know how to calculate the change in momentum when the particle is neither in x nor in y direction. You need to take components. Clear? Okay. Yes, sir. This is another question. I think we have taken a lot of time. Okay, let's do one more question. Okay, lot of questions are there. Okay. An electron travels a distance of 0.1 meter in an electric field of intensity something this. Enters perpendicular to the field with a velocity this one. What is the deviation in its path? Okay. Let's suppose. Let's suppose a electron is coming this way. And in this region, starting from here, there is an electric field. There is a electric field in the upward direction E. Clear? So due to this field, when this charge enters, a force is exerted on it in the downward direction and it goes something like that. Clear? According to the question, it has traveled a distance 0.10 meter in the horizontal direction. In this direction, it has traveled 0.1 meter. Let's suppose this distance is r. You need to find its deviation. Its deviation means its original path is something like that. If field were not there, its original path will be something like that. So its deviation will be something this one, y. This is the deviation of the particle. We need to find out this deviation, this y we need to calculate. Okay. For this, listen to me. This is the case of simple projectile motion in which a particle is projected horizontally, and you need to find out its y displacement. Clear? So let's just do it. This is, let's suppose, origin. So I am applying in y direction. I am applying the motion in y direction. So the displacement in the y direction is negative y is equals to ut minus half gt square, something you have studied in kinematics in projectile motion. So initial velocity in y direction is 0 because particle is moving horizontally according to our diagram. That means 0 minus. Why I am taking minus? Because the acceleration, just write down the acceleration. You can see that this is electron. So acceleration will be in the downward direction. So what is the acceleration? E by m. Okay. Nobody knows how it came. I will explain it. So I am making a box here again to explain you the acceleration. I am taking a box. The force on the electron will be Q into E. Charge is E. Electric field is E. Clear? This is the force. Force you can write it as m into A is equals to E into E. So acceleration is what? E divided by m. In which direction this acceleration will be? In the downward direction. And what is the assumption? What is the sign convention? That downward direction we will take as negative. So that's why s equals to ut plus half at square, the acceleration will be minus E by m. That is E by m. Y is equals to ut minus half a t square. Clear? Okay. So minus and minus can be cancelled. This y will be written as E t square by 2m. Clear? Let it be equation number 1. Now in x direction, if I say in x direction, okay, if I apply the equation again, there is no acceleration in the x direction because field is in the y direction and charge is entering perpendicular to the field. So there is no acceleration in the x direction. So distance is equals to speed into time. So what is the distance it has covered in the same time is r. So distance is equals to speed. It enters with some velocity. Let's suppose this velocity is v. V into time is t. So time t can be written as t is equals to r over v. Put this value of t in equation 1. Uh, After putting this value, y is equals to e t square means r square by v square divided by 2m. Now everything is known. Charge of the electron, electric field, this r is 0.1. Mass of the electron, velocity of the electron, you can calculate y. So I'm not going to calculate it because time is very less. We have actually invested a lot of time. So I'm just moving further. You can place the value, you will get the answer. Clear? Moving further to the next question. A mass of 0.5 kg moving with a speed something like this on a horizontal smooth surface collides with a nearly weightless spring of some constant. The maximum compression. Okay. You can see I can draw the diagram here again. This is the surface. There is a spring. This is the ball. Its mass is m, let's suppose. Its constant is k. Now, listen to the question. The maximum compression of the spring. What does it mean? The maximum compression is when like suppose this is the ball which is coming and striking. The spring will compress, and it finally stops compressing. At this point, what does it mean? It means that the ball has lost all its velocity. That means you can say the all the kinetic energy of the ball is converted to all the potential energy of the spring. Potential energy of the spring. When? When it will happen? At maximum compression. What I'm saying? Initially, ball has some kinetic energy. It strikes the spring. Spring compresses to the maximum. That means ball has lost all its kinetic energy at that particular moment. After a spring will rebound and ball will again gain some kinetic energy. That's another case. For maximum compression, all the kinetic energy of the ball is transferred to the potential energy of the spring. So that's what I have written. So kinetic energy of the ball is what? Half mv square is completely transferred in the form of energy of spring, that is half k x square. Half and half will be cancelled. Mass is 0.5 kg. 0.5 kg means 1 by 2. Velocity is what? Velocity is what? 1.5. Can you see it as 3 by 2? Is it clear? 3 by 2. We can write 1.5 as 3 by 2. So square if you do, it will be 9 by 4 is equals to k is what? 50x square. Done, 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 done. So this is again a calculation. X square will be 9 divided by 2 into 4 into 50. Okay. Okay. Can you see that 50 into 2 is 100? So that can be written as 9 by 100 into 4. Now x will be square root of this, that is 3 by 100 square root is 10. 4 square root is 2. So 3 by 20. 3 by 20 meter. 3 by 20 meter, you can write it 3 by 20 meter. If you can simplify it in the terms in decimal, you can simplify it. That will be another thing. But is this question clear? Moving further. In the given figure, the capacitor C1, C3, C4, C5, C1, C3, C4, C5 have a capacitance 4 microfarad each. C2 has a capacitance 10 microfarad. C2 has a capacitance 10. This is 4, this is 4, this is 4, and this is 4. Then effective capacitance between A and B will be, okay, this is nothing but a Wheatstone bridge. This is nothing but a Wheatstone bridge. How you can draw it? This is Wheatstone bridge. Okay, I am drawing it with resistors only. My bad. This is a Wheatstone bridge of capacitors. You can redraw the diagram, something like that. All these are 4, 4, 4. 4 and this is of 10. This is balanced wheat-stone bridge. So this 10 microfarad capacitor is useless. So in this situation, these two are in series, these two are in series, and they combined are in parallel. So if these two are in series, they will be equivalent capacitance of 2 microfarad. Clear? And these two, for these bottom two, there will be another equivalent capacitance of 2 microfarad. This is point B, this is point A. Now they are again in parallel. If they are in parallel, the equivalent capacitance will be 2 plus 2, 4 microfarad. So 4 microfarad will be the result, will be the final answer. Very simple question, simple Wheatstone bridge, nothing else. So this is going to be the last question of our session because it's already too late. A ball of mass M, okay, now listen to me, is attached to the end of a string having length this much. The ball is rotated on a horizontal circular path about vertical axis. Okay, so let's draw the diagram. I will try to draw the diagram. This ball is rotated in a horizontal circle, something like that. I will again draw it, don't worry. Let's suppose something like that. This is the vertical hinge. This is the string. Let's again draw it. This is the mass. Okay. Mhm. What's going to happen? Now, what we need to calculate here in this particular question is the maximum tension that the string can bear is 324 Newton, the maximum possible value of angular velocity of the ball. That means omega they are asking. They are asking the value of omega. Clear? So let's draw the FBD of the body. Can you see that this is going to be mg? I will place the value of m later. This is going to be the tension T. Let's suppose this is the angle theta. This is the center. So you can divide the components. You can draw the components here. If I change the color of the pen, this component will be T cos theta, and this component will be T sin theta. Is it clear to everyone? So this T sin theta, this particle is moving in the circle like this. This is moving in the circular path. And this T sin theta is providing the necessary centripetal force. So you can write it as T sin theta is providing the centripetal force. That means mv square by, let's suppose R is the radius. R is the radius. Or in terms of omega, you can write it as m r omega square. So T sin theta is m r omega square. Let's suppose it is equation number 1. And T cos theta is equals to mg. Clear? Now, we need to calculate this omega square. Lot of values are given. Now, you can see that. Look at me. The maximum tension is given as, if I see from the diagram, the maximum tension is given as 324 Newton. Now, listen to me. If you increase the angular velocity, if you increase the angular velocity, then tension will increase, and at a certain value of angular velocity, this string will break. This string will break. Is it clear to you? Is it now? Can you see that if I complete this triangle, so this is a right angle triangle, and in this right angle triangle, this is the radius r, this is the length of the string, which is given as L, which is 0.5, value is given. So can you calculate the value of sine theta? Sine theta is what? R over L. Is it clear? Sine theta is what? R over L. So now from equation 1, if I put the values, T sine theta is what? R over L is equals to m r omega square. So this r and r can be cancelled. So omega square can be written as T divided by m into L. Is it clear? T is the tension, maximum tension, and this maximum tension is given as 324 Newton divided by mass is given as something 0.5. 0.5 can be written as 1 by 2. This length is given as 0.5, which is 1 by 2. So omega square is nothing but 324 into 4. So omega is 18 into 2, that is 36. Omega is 36. What is the angular velocity of the ball? That is 36 radian per second is the right answer. So as I told you, we have invested a lot of time in this session. So this is the last question of the session. I am ending the session now. I hope you have enjoyed. If you have any doubt, this equation, we can omit this equation. There is no need to write this equation. There is no need to write this equation. Clear? Okay. So I hope everything is clear till now. We are ending the session now. Bye, everyone.